Hello, everyone. So this week we are only doing 2 lessons, so you look out, we're not doing 3, so that'll help make things a little bit easier on you guys since it is just before Easter and we have a little bit of spring break here coming up. So first thing we're looking at today is 7.4. For the most part, you guys did pretty well at getting your assignments in. I was really happy with a good portion of you getting those done and in and submitted. Awesome job, you guys. And the keywords, you guys did amazing with that. For those of you who haven't done any work, you still need to do the work. So even though it is passed and closed out, you can still email it to me if it doesn't let you submit anything. But do please submit things to me because guess what? It's in there as a 0. So there's a lot of you who you may want to check your grades right now, okay? Because guess what? You're going to have to do this at some point or another. So you might as well get it done now. All right, so like I said, we are looking at 7.4 today. Within 7.4, we have more with circles, so lots of circle things going on. So looking at this, we are given either the area, circumference, or radius, and then we're going to find the other 2. So I'm going to show this on my whiteboard. That way it's easier for me to write. Okay, so our formulas for circumference and area that we talked about before. Circumference is 2 pi r, so 2 times the radius times pi. And remember with circles, finding the radius and the area, finding the circumference and the area, you can always leave your answer in terms of pi rather than taking and multiplying everything by pi and getting a big long never-ending decimal. So I'm fine with you leaving your answers in terms of pi. And then area is pi r squared. So we're going to look at number 2 and number 3. Number 1, you're given the radius. All you have to do is plug it in and solve. So I'm not going to show one of those because we've already done those, and you guys should know how to do those fairly easily. Those are things that we've done before. All right, so looking at this, we're given that the area is 9 pi feet squared. So our area formula was area equals pi r squared. So we're subbing in what we know. We know the area is 9 pi, and it equals pi r squared. So now we need to take and solve. So we're going to divide both sides by 9 pi. Oops, not 9 pi. I'm doing my math all wrong. Divide by pi. That'll cancel the pi out here and the pi out here. So then we have 9 equals r squared. Well, how do we get rid of a square on a number? We take the square root, or on the letter. So r equals 3. So our radius is 3. Now we need to find the circumference. Circumference formula, c equals 2 pi times the radius, which was 3. 2 times 3 is 6. So our circumference is 6 pi. And this would be 6 pi feet, and this would be 3 feet, making sure to have those labels on there. All right, hopefully that's not too bad. So it's all about taking and solving for the radius first from what you're given. So using these 2 equations. So if you don't have these 2 equations wrote down, I suggest you get them wrote down because they're going to be very beneficial in your solving. All right, so for number 3, we are given the circumference. It's 8 pi yards, and we need to find the area and the radius. So circumference equals 2 pi r. Our circumference was 8 pi, so we have 8 pi equals 2 pi r. Now we can divide both sides by 2 pi. So that all cancels out. We're left with the radius equals. The pi's cancel, and then 8 divided by 2 is 4. So our radius is 4 yards. So now we just need to do area. Our formula for area is area equals pi r squared, where r was 4. So 4 squared is 16. So area equals 16 pi yards squared. So 16 pi yards squared. So hopefully that section isn't going to be too bad for you guys. Like I said, it's all about these 2 equations up here. So make sure if you don't have those down, you get those down now. So that way you can take and solve these. So it's all about finding the radius from the given information that you have. Okay? All right, perfect. So That's what you're doing for 1 through 6. Make sure you do both parts of each of them because each part is going to be worth a point, so that's pretty important. Now, the next part that we are looking at is finding the area. So I'm going to show you guys on the document. So looking at this, we're finding the area and perimeter of regular polygons, specifically these regular polygons. So for each of the regular polygons, find the measure of an interior angle and the perimeter and the area. So we have 3 things that we have to find with each of these. Now, this isn't going to be quite as simple as just what we would do with finding a rectangular square. It's not just base times height. It's a little more complicated than that because these are regular polygons and we don't just have a base and a height. Now we have our formula for solving is 1/2 times the apothem times the perimeter. Oops. So this is our formula right here for area of a regular polygon. It's 1/2 apothem times perimeter. Now, you're probably wondering what on earth is an apothem? So an apothem is going to be, so if we draw the center of this figure and out, that'd be what's known as the radius, because that'd be the radius for the circle. Then the apothem is going to be the line down the middle. You can't see that line. It'll be the line that comes from the center to the middle of the side of our figure. So depending on the figure, so this one's a hexagon. So it'll come to the side of the hexagon, and it's going to intersect at it's going to be perpendicular. So it's going to intersect at that 90-degree angle. So that is the apothem, that length there. So it takes a little bit of solving to take and find that. Sometimes you're given the apothem, and then you'll have to solve for what the actual side length of the figure is. Other times you're given the radius and you have to solve for both of them. It just kind of depends on what information they give you. So first and foremost, we have to find the measure of one interior angle. So an interior angle would be like this angle right here. So when we're taking and doing these, we have to take and think about how many sides there are and calculate it. So in a hexagon, there are 120 degrees. We get that from the fact that hexagon, if we solve for the central angle, we take 360 divided by 6 because there's 6 sides. So that would give us 60 degrees. And then each one of these angles is going to be double of that. So it's all about taking kind of solving with your triangles. For perimeter, you guys should know perimeter. It's the distance around the outside of this. So one side is 8 inches. So there's 6 sides. 6 times 8 equals 48. Excellent. So it's going to be 48 inches is our perimeter. And then our area. So this is where we're using the 1/2 times the apothem times the perimeter. So we already know the perimeter. So we got that part solved for. But now we need to figure out what the apothem is. We don't have that right now. So I'm going to take this little figure that I drew down here, this triangle, and draw it down here. So we've got this right here. And this is 8 inches. Oops. So this is 4 inches. This is 4 inches, right angle. All right, so we have this right here. Now, like I said earlier, finding the central angle about this circle is the 60 degrees because we took 360 divided by the number of sides, which was 6, and that gets us that angle. So these angles here, this one's going to be 30. This one's also going to be 30. And what are you noticing? We have a right triangle, and we are missing a side. Guess what we're going to use? Sine, cosine, tangent, SOHCAHTOA. You got it. So looking at this from our angle of reference of 30 degrees, we have the adjacent side and we have the opposite side. So which of our functions are we going to use? Tangent. You got it. So we're going to have tangent 30 equals opposite over adjacent. So then remember the x and the tangent 30 will switch places. So we're going to have x equals 4 over tangent 30. And so now we plug that into our calculator. So let me get my calculator out. So we're going to take 4 and divide it by tangent of 30. So if you have a calculator like this, it'll look just like that. If you're doing it on your phone, remember you have to take the tangent 30, make sure you know what that value is, and then you'll take 4 divided by that value. So remember you have to do it a little differently on the phones than you can on the calculator. And we get that it's about 6.93. So x equals 6.93. So that is our apothem. So now we're going to take 1/2 times 6.93 times 48. So we're going to multiply all those things together. So we take 1/2 times 6.93 times 48. And we end up with 166.28 inches squared. So there, whoops, sorry, can't see that. So there is our area. So finding the perimeter, obviously pretty easy when you're given a side length. Finding the apothem refers back to our trigonometry. So knowing how to do that trig work is very crucial here. So remembering SOHCAHTOA. So remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those are crucial for being able to solve for that apothem when it's not actually given to you. All right, so we're also going to look at another one from this section because there is one of them that was nice and it gave you the apothem, but it didn't give you the side length. So that means you're going to have to take and solve for what the side length is going to be as we take and do this. So here we have an octagon. So an octagon, how many degrees is that going to give us for our angle? Take a moment to think. So this one's a little different. We won't just multiply it by 2. So central angle would be 360 divided by 8, and 360 divided by 8 gives us 45 degrees. That means each one of these inner angles, let me draw out this. So this would be the 45, and then split this down the middle. So 45 divided by 2 would get us 22.5. So 90 minus 22.5 is 67.5. So that means this angle here is 67.5. And 2 of those would give us 135. So our angle is 135 degrees for an interior angle. And remember, interior angle is these angles here, not your central angle. So don't get those confused, okay? All right, so now our perimeter. Do we know what the side length is? Nope, we do not. So referring back down here to this little triangle. Let me get a little closer so you can see. So we need to find what this value here is. So the full side. Oops, that's a little too far to one side. So the full side. And we know that the apothem is 10. So we can solve for half of the side, and then we'll double it to take and get what the full side length is. So using the whole angle is 45, using 22.5 as our angle of reference, we've got the adjacent side and the opposite side. So we're going to use tangent again. So tangent of 22.5 equals opposite, which was x, over adjacent, opposite over adjacent. Goodness, brain not working. So opposite over adjacent, so our opposite was x over our adjacent, which was 10. Now in this case, we're just going to do 10 tangent 22.5 equals x. So for those of you with calculators, you'll type it in, 10 tangent 22.5. For those of you with phones, you'll take and do the tangent of 22.5, and then you'll multiply that by 10. So we end up with 4.14. Now, x is just 1/2 of the full side length, so we have to multiply this by 2. So times that by 2, and we'll end up with 8.28. So our side length is 8.28. And how many sides are there in our octagon? There are 8 sides, so times 8 equals 66.27. So our perimeter is 66.27. So now, let me get that right up here. Now for the area, we already know the perimeter and we know the apothem. So area is just 1/2 times 10 times 66.27. So 1/2 times 10 times 66.27 is going to give us 331.35. And depending on how you round these things, you may get a decimal that's slightly different than other people. That just all comes with the rounding. So remember, rounding technically kills people, but sometimes we have to round because the numbers are they go on forever, so we can't just use never-ending numbers all the time. So it's okay if your number is a little bit different. As long as it's close, you'll be okay. All right. Hopefully this kind of makes sense. I know you're probably panicking because obviously there's a lot going on in these problems. Remembering sine, cosine, and tangent and how to use that to find missing parts of triangles is going to be crucial. So that's why we went through the trigonometry and going through solving all those triangles and having to find all those different parts, despite how much you guys despised how much we did that. You have to know how to do that in order to do the area of these figures. So hopefully you guys know it fairly well. You're getting pretty good with it, so I think you guys should be decent. All right, so your keyword for this lesson is area. So we were looking at area of regular polygons just now. The next thing we're going to look at is the area of a sector of a circle. So I'm going to show you back on the actual slide or assignment real quick. So finding the area of a sector. If a circle is cut into 4 equal pieces, then the area of one piece would clearly be 1/4 of the area of the entire circle. If a circle is cut into 6 equal pieces, then the area of one of the pieces would be 1/6 of the total area, and so forth. For n equal pieces, the area of one piece would be 1/n of the total area. With this in mind, consider the area of a sector that is 1 degree in size. A circle split into sectors are all 1 degree in size that would have 360 sectors. How could you find the area of just one of them? So here's an example right here for if you guys get stuck when you're taking and doing this on your own. We're going to do number 13 together. So finding the area of the sector, it involves finding the area of the whole circle and then multiplying it by C over 360. Now the C here represents the central angle, so the angle that you're given over 360. So that represents the fraction of the whole circle that you're working with. So in this one, our angle is 160, so we have 160 over 360 times pi, radius squared. Our radius is 5. So now we take and solve this out. So 160 over 360 is, hang on, 4/9 times 25 pi. So now you're just going to multiply 4/9 and 25 together. So times 25. And then times that by pi. So you will actually multiply by pi in these. We want a decimal on these ones. So we're going to end up with 34.9 inches squared. So these ones, you just plug everything right in. You'll get a decimal. So this is the area of this portion of that circle. Hopefully that kind of makes sense. So this is your formula for that, so make sure you get that formula down. And remember, C represents central angle, not circumference, so that could be an easy mistake you guys make, but C represents the central angle. So that means whatever angle you're given you're going to put that and divide it by 360 and then multiply that value by the area of the circle, of the whole circle. Okay? All right. So, like I said, area is our keyword for this lesson, so make sure you get that submitted. It is worth points, so it's a nice, easy 10 points for you guys during this time. Hopefully you guys kind of get this, and if you have any questions, by all means, feel free to contact me during office hours. Just shoot me an email, and I will be more than happy to help you. Remember, office hours are Monday, Wednesday, Friday from 1 to 2. All right. Good luck. Hope it all goes well, and happy mathing.